Hi, mathletes! Today we're going to investigate the areas of squares, rectangles, parallelograms, and rhombuses. So in this video, we will explore how to find the area of different quadrilaterals by understanding their unique properties and using area formulas. We'll investigate and compare squares, where all sides and angles are equal, rectangles, where equal opposite sides and right angles, parallelograms that have equal opposite sides, but the angles may not be right. And the rhombuses, where all sides are equal, but again, the angles may not be right angles. We'll use measurements and formulas to discover how the shape of a figure affects how we calculate its area. So let's dive in and make sense of area, one shape at a time. Let's start with a square. For a square, all four sides are equal. Therefore, if one side is 4 centimeters, that means all the sides need to be 4 centimeters. Another thing about squares is that all the angles are equal to 90 degrees. And to show that they're 90 degrees, you'll see that there's a little box here. So if one's 90 degrees, they all have to be 90 degrees. So the area of a square is the side multiplied by the side. We sometimes write it as S multiplied by S, or the area equals S squared. So I can replace the length of the side, which is 4 centimeters, and square it. So 4 multiplied by 4 is 16. So the area of the square is 16 squared centimeters. Now let's look at the rectangle. For a rectangle, opposite sides are equal. Therefore, if the top side is 7 centimeters, the bottom needs to be 7 centimeters. If the left side is 4 centimeters, the right also has to be 4 centimeters. Also, in a rectangle, just like in a square, all the angles are equal to 90 degrees. Again, you can see the little box here. So they're all 90 degrees. So the area of a rectangle is the base multiplied by the height, which again we can write as b multiplied by h. We can replace the b with the 7 because that's my base, and we can replace the h with the 4 because that's my height. And the product of 7 and 4 is 28. So the area of this rectangle is 28 squared centimeters. Now let's look at this. We have a rectangle, and I'm going to cut off a diagonal of it. So I'm making a right triangle, and I'm going to move it to the other side. So that's what a parallelogram looks like. So what do you know about the area of a rectangle and the area of the parallelogram? This is the one I started out with, and then I cut off that corner and moved it to the other side. So what do you think when you compare this rectangle to the parallelogram? Is it the area bigger? Is it smaller? Or would it be the same as the area of the rectangle? You might want to pause the video here and think about this. Well, let's look at this rectangle. It's 6 for its base and its height is 3. Now let's look at the parallelogram. It's also 6 across and its height is also 3. So if we look at this parallelogram, the area is just like with our rectangle. It's the base multiplied by the height. And the opposite sides are equal. We can show that by putting these lines like this. And these two go together. So far, it sounds like a rectangle. But what makes a parallelogram different than a rectangle is its angles. They are not right angles, but the opposite angles are equal. So in other words, if this is 120 degrees, this would also have to be 120 degrees. And these are also equal. So 2 pairs of equal angles. So let's say that the top and the bottom are both 8 centimeters. And the height is 3 centimeters. So when I look at a parallelogram, the height needs to be perpendicular to the base. In other words, it has to make a right angle. I like to think of it like I'm standing here and I drop a rock, and the rock falls straight down. So we do not measure the angle or diagonal. We measure the straight line so that it makes a right angle. So this is 3 centimeters. We could also measure it on this side. It's also 3 centimeters if you like to think of it like this. This is where I was cutting my line and I brought it over to the other side, okay? So the area is the base multiplied by the height. So we can say that the base is 8. The height is 3, so the product of 8 and 3 is 24. So the area of this parallelogram is 24 squared centimeters. Now let's look at the rhombus. In a rhombus, it's similar to a square that all sides are equal. But in a square, all the angles are also equal. They're all 90 degrees. In a rhombus, it's similar to a parallelogram for its angles. We'd say that all sides are equal and opposite angles are equal. So these two are the same measurement and these two are the same measurement. To find the area of a rhombus, it's similar to finding the area of our parallelogram. It's base multiplied by height. Again, b multiplied by h. If the base is 12, the height also has to be perpendicular. So I have to where I would drop my rock. So I could drop it here to make it perpendicular to the base. I could also put a dotted line in here and drop it. So let's say that the height is 10. We would replace the base with 12 centimeters, the height with 10 centimeters, and the product of 12 and 10 is 120. So the area of the rhombus is 120 squared centimeters. So even though these quadrilaterals have different shapes and properties, we can calculate their areas using clear formulas and visual reasoning. In this lesson, we reviewed the definitions and properties of squares, rectangles, parallelograms, and rhombuses. We used the formula area equals base multiplied by height, or for squares, area equals the s squared. We connected area formulas to real measurements and diagrams. Math isn't just about memorizing formulas, it's about understanding how shape, size, and structure work together. If you like this video, click the like button. Better yet, leave a comment. And if you haven't subscribed, subscribe to this channel for more interesting videos to make math fun and easier for you. As always, thanks so much for watching.